we want to know how many four-letter words, real or nonsense, that means they can be real words or just four letters of nonsense words, can be formed using only the first 7 letters of the alphabet. So here's how I'm going to look at this. What I'm going to see is 1, 2, 3, 4-letter words, right? I'm going to write a slot for each of the 4 letters from left to right. So first letter, second, third, and fourth letter. And now I'm going to try to figure out how many ways can I make each one of these choices here. So I want just the first 7 letters of the alphabet. So how many choices do I have here? Any one of those 7 letters. So I have 7 choices here. And now we're told that repetition is not allowed. So whatever letter I pick here, I cannot use here. So I had 7 letters to begin with. Now I have only 6, and now only 5, and now only 4. So there we have it. What we're going to write here is 7 times 6 times 5 times 4. And if you actually multiply that out, I think that comes out to 840. Now, problem 2, what we have are 12 people, and we're going to put them in a row of 12 seats. So I'm going to draw this here. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And how many ways can we place these people? Well, look, in the first seat here, in the leftmost seat, we could place any one of those 12 people. So there's 12 ways to make that decision. Then in the second seat, we have only 11 people from which to choose. Right, one person's already gone here, so out of 12, we've put 1 here. It means we have 11 people left, so we could put any one of 11 here. And then likewise, for the third position, we've already seated 2 people, so out of our 12, 2 are gone. There's 10 people left, so we could put any one of those 10 here. Then 9, 8, ... all the way down to that very last person. So this looks like it's going to be a 12 factorial, and that's pretty big. So if you just want to leave it as 12 factorial, that's fine. When I multiplied it out, I got 479,001 and 600. But when numbers are big like this, you can just leave that as 12 factorial. Let's go on to number 3 here. So what we've got is 5 questions. So we've got 5 questions. Right away I'm thinking I got the first question, the third, the fourth, the first, second, the third, the fourth, and the fifth. And now, how many ways can we answer each question? And we have to answer each question. So how many ways can we answer the very first question? Well, there's A, B, C, D are our choices, so I think there's 4 ways to answer that one. And then you come to the second question. Well, there's still 4 ways to answer that one, right? A, B, C, or D. In fact, there's 4 ways to answer each one of these questions, so by the multiplication property, we're going to get 4 to the 5th. And that's okay, we can leave it like that, or if you actually multiply it out, that comes out to 1024. So in here in problem number 4, we have 4 history courses, 4 science, 3 math, 5 philosophy, and 5 English courses. So we want to know if a first-year student takes 1 course in each area, how many different course selections are possible. So let's look at it this way. That 1, 2, 3, 4, 5. We could have history, science, math, philosophy, and English. And how many choices do we have for each one of these? Well, there's 4 history from which we can choose, 4 science, 3 math, 5 philosophy, and 2 English courses. And it's a multiplication principle. And when I make that multiplication, I've got 480 different course selections.